hopefully it works, to send this out to everybody. And our timeline right now looks like we'll be doing empirical formulas today, and then we'll review next class. I did make a new practice review that's going to be online, and it'll be pretty similar to the test you're going to take next week. It's got a multiple choice part, and then it's also got a structured response part that you'll have to take a picture of it and send it to me so I can grade that separately. So, but the plan right now is to finish up the mole unit, and then hopefully everybody's got their next packet for the next unit, Unit 6, which is stoichiometry, and we'll be picking that up after the mole unit and seeing if we can get through that one okay. So it's looking more and more like we won't be going back to the building. That's why I'm here now. They kicked me out of the building. So I did as many labs as I could do today in the school, and now I'm back here. So this is my lab away from home. It's nobody's in here. It's a separate building from my house. It's actually a post office from 1800s. Wow. A general store. It was a general store too. It's also my wife's photography studio, which is why I have the nice lights and stuff in here. All right, so I wanted you to take a look at the book that we had on page 19 for empirical formulas. And I wanted to do a couple more examples so you could see how empirical formula calculations work. It's probably, besides the mole problems, one of the harder concepts in the unit that we've done so far. So there's a lot of parts that kind of come together. So we're going to do a couple of examples from the unit. So I'm just going to pull that up here real quick. So yeah, we had assigned questions 1, 2, 3, and 5 before. And if we look at that unit, oops, where did I put it? Oh, that was it. Yeah. All right, so if we look at the questions 1, 2, 3, and we skipped over 4, and you did 5, hopefully. But were there any questions about those that you had? Because we could go over that. Anyone? Any of those that you had questions on?
Can you do number 2? I just want to see, just check.
Yeah, we can do number 2. All right, so in number 2, the problem was looking at a orange compound, and it has 26.6% potassium. It's got 35.4% is chromium, and it's got 38.1% oxygen. it's been a little on this, but what you're supposed to do with these numbers is convert them to moles, and then you're going to find you're going to divide by the smallest number of moles, and then that should give you whole numbers, or you might have to round it off, because what we're ultimately trying to do is figure out what this formula is. The numbers in that formula is what we're looking for. So the first step is to convert these to moles. And the way we do that is, well, these are in percentages right now. Take a step back, sorry. Typically we can convert moles when we know how many grams we have. But because these are in percentages, we have to convert them to grams, which sounds kind of like something we haven't done before, but in reality, these percentages, if you assume that the weight of the compound is 100 grams, then you can just say that we have 26.6 grams of potassium, we have 35.4 grams of chromium, and we have 38.1 grams that is oxygen. Because if you look, those add up to 100 grams total. So you can just pretend that you have like a 100 gram mass of the compound. Then we can convert them to moles, because we know how to convert grams to moles. We need a periodic table, which I brought one home, so you could see it pretty easily. So we have potassium right here is 39.1. Well, it's 39.09, but we're going to round it up to a 39.1. The top is 1 mole on that. So it's 1 mole over the formula mass. Then we have chromium. Chromium is a transition metal. It's got a weight of 52.0. So 1 mole over 52.0. Sorry, my pellet stove is turning off now. And then we have oxygen here. Oxygen having a weight of 15.9994, so 16 for that one. 16.0. And 1 mole on top. So this is our grams to moles conversion that we've been using for this unit. And all we have to do is take the 26.6, divide it by the 39.1, and we get 0.68. Then we do the same thing for chromium, 35.4 divided by 52.0 is 0.68 again. And then lastly, we have oxygen, 38.1 divided by 16 gives us a mass, well, not a mass, moles of 2.38. Okay, so we converted grams to moles for all 3 of those, and now we have to divide all of them by the smallest number of moles, which is the 0.68. So we're going to divide all of these by 0.68. These two are 1, right? 0.68 divided by itself is 1. But the 2.38 divided by 0.68 is 3.5. So the formula right now looks like K1CR1O3.5. But we can't have a fraction in our formula. So what should the formula be?
Multiply by 2.
Yeah, you have to multiply them all by 2. Good. So you multiply the chromium by 2, the potassium by 2, chromium by 2, and oxygen by 2. And that gives us a new formula of K2CR2O7. So that would be the empirical formula for that compound. Okay, so that's the general setup for those problems, though, is you have to start with grams, or if your percentages, you have to change it to grams just by literally writing grams. And then you convert them all to moles by dividing by the formula weights off the periodic table. And then that will give you the amount of moles of each one, and you divide them all by the smallest number of moles, and that will give you the numbers from the formula. Sometimes you have to round them, sometimes you have to multiply them by 2 like we did here to get our potassium chromate is the name of that compound. So, but that's the general process for those problems. All right, so we skipped over number 4. It wasn't one of the homework questions. So I'm going to do that one as an example, just so you see another example of doing these. Or maybe I should do one from the practice problems. Let me just take a quick peek at that. Oh, there's some really hard ones on there. We had a lot of practice that we just kind of skipped over. Yeah, I remember we were pretty rushed in the notes. We're going to do, let me pull it up on the screen so you can see it. Hopefully everybody can hear me okay. Yeah, we're going to do problem 4 on page 17. That's probably going to fall on me. We'll wait for that. So we're on page 17, and we're going to do problem 4. And I'd like you to later do on the other page, the homework question number 4 would be a good one to do. Oh, you're writing on there. How'd you do that? Can I write on there? That's pretty cool. All right, I'm just going to write down the details real quick before we do the problem. So we're trying to figure out how much water is in this. So we're looking for the amount of H2O in this hydrated Epsom salt. And in the experiment, we started with 1.68 grams of the hydrated material. So that was our mass. And then our final mass, after heating it, we did it, oh wait, I did this lab, but I'm gonna send it to you, but then we heat it up and it's 0.824 grams afterwards. And they wanna know what the formula is of the compound. All right, so I wrote down some of the important details. Probably not all of them, but most of them. All right, so the idea is that this is what you start with. There's a certain amount of water here. We're looking for that number. And what they do is they actually heat this up and it makes MgSO4 and then water. The water breaks off. So before it had the water attached to it, afterwards the water's gone. It's going to be like a vapor. Before it had a weight of 1.68, and then afterwards it has a weight of 0.824. Okay, so it went from 1.68 grams before to 0.824 grams afterwards. So looking at that information, we can figure out how much water we lost by just subtracting it. So the first thing we want to do is take the 1.68, and we're going to not divide. Hold on. We're going to subtract the 0.824 from that, and that gives us a mass difference of 0.856. So that's how much water we drove off in that reaction. Okay, so we know how much it weighed before, we know how much it weighed afterwards, and we know how much water we lost from the reaction. So how do we figure this out? Well, that's the amount of grams, okay, of water. And we know the grams of the magnesium sulfate, so we can use that information to figure out the mole ratio of water. This problem is quite a lot different though, because we're actually not going to use the 1.68 anymore. We're just going to use the 0.824 and the water, H2O, as 0.856. And we're going to convert those to moles. So the process is still the same. We're going to convert these to moles, but we're converting them to moles of this whole thing and to moles of this whole thing, because we're looking for the ratio of this to this time. Because we already know what the formula of manganese sulfate is. We know it's MgSO4, and we know the formula of water is H2O. The thing we don't know is how much water there is compared to magnesium sulfate. So we're looking for the ratio of that. But the first thing is we need to convert to moles to do that. And now it's a little harder because it's this all together and this all together. So we need to find the formula weight of the entire compound. All right, to do that, we need to use our periodic table and look up all the weights. So we have magnesium, which is 24.3. We have sulfur, which is 32.1 if you round it out. And there's only one of those. And then we have 4 oxygens, so 4 times 16. Oxygen's 15.99, as we talked about before. So we do 24.3 plus 32.1 plus 4 times 16 gives us 124.4. All right, that's going to go down here. And now we have to do the same thing for water. So for water, we have 2 hydrogens. Hydrogen is 1.00795. We just do the 1.0. And then we have 1 oxygen. We already know oxygen is 16. So water has a weight of 18. So that would be the denominator for that conversion. All right. Finding moles, we take the 0.824 and divide that by 124.4. We get a amount of moles of 0.00662. And then for our water, 0.856 divided by 18, we get a mole amount of 0.0476. Obviously, this one's way smaller, the 0.00662, so we're going to divide them both by This one will come out to 1. And this one comes out to 7. Well, I'm lying a little bit. It's like a 7.18, but it's close enough to 7 that it's 7. It's not like a 7.5 like we had last time. So it's supposed to be 7. I probably over-rounded something on here, but the overall formula then is MgSO4 with 7 H2O. Okay, that's where that 7 goes. It goes right here. And it's the ratio of moles of water compared to the moles of magnesium sulfate. So that's your formula for that problem. Okay. Now that is exactly like the, let me pull up the worksheet here. So that one was this question right here. I don't know how you guys wrote on that. That was kind of cool before. And what I'd like you to do for practice is if you haven't finished the homework, LOL, can everybody see that or is it just me? I don't even know. I'm surprised nobody's drawn like a penis on there or something. Oh, don't no. Is this Cyrus? Who is this? Thanks, yeah, you just had to do it.
That was not me.
All right, just checking. What I'd like you to try to do is number 4 on top of any of the other questions that you haven't done for practice yet is see if you can get the homework question number 4 to work. It's set up just like this one, so try to work your way through that and then you know, do any of those other ones that you haven't done yet. We're gonna spend, I'm gonna